Hello, and this is my brief video explanation on some of the types of sorting that you might expect to see in a Java program. This is a topic that gave me some difficulty, and I think warrants some additional exploration. There are far too many types of sorting methods, with many of them being far too complex to adequately cover in this video, so I will focus on the sorting methods most frequently tested on in the AP Computer Science curriculum: bubble sort, selection sort, and insertion sort. However, before I can go too in-depth on each of these specifics, I have to cover the concept of algorithm efficiency and Big O notation. Big O notation is the term used to mathematically categorize the efficiency of an algorithm in terms of both space and time complexity. For the sake of this video, I will be focusing mostly on time complexity. With this in mind, we can begin to look at how each of these sorting methods work. To show this, I have constructed a program here with an integer array containing some very simple data that we can use to visualize how each of these sorting methods work. For the sake of this argument, we'll be only sorting these sets of data from least to greatest. Bubble sort is a pretty good sorting algorithm to start with because it is one of the easier algorithms to comprehend and implement. Now, it must be noted that in almost all situations, the big O value of this algorithm is O n squared, making it very inefficient. However, in certain instances, the big O notation can be very efficient at O of n. So how does this sorting algorithm work? In sort, it reads every adjacent pair of numbers in an array and swaps them if the larger or smaller integer, depending on how the array is being sorted, falls either first or second in that pair respectively. It repeats that process until it reads that there is no more data left to be sorted, which it does in this case by using a Boolean variable whose value is reliant on the outcome of this Boolean expression to control the external do while loop. And that's the way the process works. And to illustrate this, let's add in an implementation of the bubble sort on our int array. And let's run this method. And we can see how this works with each time this program runs. We can see that the data is sorted with each pair of numbers being compared against each other. Selection sort is another perfectly valid method of sorting data in a list. However, for all cases, its big O notation will be O n squared, making this another resource inefficient sorting method. Selection sort works by taking the whole unsorted array and finding the minimum or maximum value in the array and swapping that with the next available index in this sorted part of the array, and then moving the index of the unsorted part of the array up one. You can see the mechanics of how this works here with this if statement being used to find, in this case, the minimum value in this array, and then they're swapped out, and we can use this output here to, I forgot to change this from the bubble sort to our selection sort. And let's run this. And then we can see how this works here with the smallest point of data and all of this being swapped out here. And then that process continues here, and then here, and then here. The last pertinent sorting method we'll be looking at in this video is insertion sort. For me, at least, this was the most difficult sorting method to understand. Much like bubble sort, this algorithm can have an average big O notation of O n squared, but in its best case scenario, it can have a big O notation of O n. This sorting algorithm involves reading each new piece of data in the list and then putting it into the sorted portion of the array while moving all other data around it to accommodate for this new piece of data and its new position. So that's what it's doing in this nested while loop here. And I kind of hard to explain properly how that is, how it's really being implemented in that. So I think the best thing to do in this case would be to work with this integer array here and use insertion sort and kind of show how that's working with the output. So let's run this here, and we can see how it gets sorted through each successive run. And well, I think that that just about wraps it up for the types of sorts that I'm covering here today. These are probably the most common ones that you'll be seeing in any testing situation, but you know, there's many other types of ones out there that are oftentimes more efficient. So those are also worth looking into. I would recommend experimenting with each of these types of sorting methods by maybe working with some larger pieces of data and maybe doing some further analysis on how each of these sorting methods work. With that in mind, I hope this video was helpful and have a good day.